Unraveling Neural Networks and Backpropagation in Machine Learning. Hello, class! Today, we will be venturing into the captivating world of neural networks and their cornerstone training method, backpropagation, in the realm of machine learning. Neural networks are a series of algorithms that mimic the operations of a human brain to recognize relationships between vast amounts of data. The algorithm for training these networked systems is called backpropagation. It represents the backward propagation of errors, meaning that the network learns by adjusting its weights and biases with respect to the error it made previously. The backpropagation algorithm moves backwards from the output layer to the input layer, propagating the error gradient. Its main task is to minimize the difference between the actual output and the desired output of the neural network. In the world of deep learning, backpropagation typically applies to feed-forward neural networks that feature multiple layers of hidden units, known as deep neural networks. The landscape surfaces that backpropagation operates on are complex, high-dimensional, and non-convex, which can sometimes make the training of these networks challenging. Activation functions in neural networks play a crucial role. They determine the output a node will produce based on its input. Common activation functions include sigmoid, TORNH, and ReLU. Neural networks use gradient descent optimization algorithms that leverage backpropagation to make their predictions more accurate. The backpropagation algorithm consists of two phases: propagation and weight update. Backpropagation requires intermediate stages. It saves each stage to use in the computation of the next stage, a technique commonly referred to as dynamic programming. An important aspect of optimizing through backpropagation is the learning rate. This determines how much an updating step influences the current weights. In backpropagation, error derivatives are passed back through the neural network so that the weight of each connection is modified proportionally to how much it contributes to the total error. Backpropagation is a supervised learning technique often used in conjunction with an unsupervised learning function to generate desired outputs. The vanishing gradient problem, where the gradients of the loss function become too small, can hamper the effectiveness of backpropagation in deep networks. But worry not. Techniques like weight initialization and the introduction of optimization methods such as ADAM and RMS-prop improve backpropagation by dynamically controlling the learning rate. Backpropagation is extensively used in convolutional neural networks, CNNs, and recurrent neural networks, RNNs, for optimizing filter values and learning sequential patterns in data respectively. In fact, neural networks trained using backpropagation form the foundation for many modern artificial intelligence, AI services and applications. Overfitting, a common problem in machine learning, can also be an issue in backpropagation. Techniques such as dropout are used to prevent it. In conclusion, the artful combination of neural networks and backpropagation is what furthers the field of machine learning every day. By understanding their inner workings and application, we are able to significantly improve our model's performance. In our next session, we're going to delve deeper into the intricacies of convolutional neural networks. Buckle up and stay excited as we are in for a fun and knowledge-packed ride.